Welcome to ClickMyProject.com. The title of the project is Image in Painting with Local and Global Refinement. So, the abstract of the project is Inpainting is derived from art restoration, also called retouching. Image in painting refers to the application of sophisticated algorithms to replace lost or corrupted parts of the image data. The main aim of the image in painting is to fill scratches in the image or photos as well as to remove larger objectives from them. The main objective of inpainting is to reconstruct the missing regions in such a way that the observer does not come to know the image has been manipulated. Image painting has made remarkable progress with recent advances in deep learning. Popular networks mainly follow the encoder-decoder architecture and possess the sufficiently large respective field that is larger than the image resolution. We propose the use of local and global refinement network where the convolution is masked and renormalized to be conditioned on only valid pixels. We further include a mechanism to automatically generate an updated mask for the next layer as part of the forward pass. Our model outperforms other methods for irregular masks. We show qualitative and quantitative comparison with other methods to validate our approach. And the flow diagram of the project is: first we need to start the program and select the data set. So after that it will apply it into data generation or mask generation. In that we are going to create the mask for our input images, then it will apply it into our training model. So in here we are using local and global refinement neural network algorithm, which is used to apply the auto encoder decoder layer, which is used to compare the original images and mask images, and it will be generated the image in painted images by using the neural network algorithm. Finally estimates the performance based on the dice coefficient score. Finally it will predict the images based on the by comparing the original and mask images and generate the in paint images. I was successfully executed my code in Google Colab. So in here, for these are the libraries that I have used in our program, and this is the pre-processing technique. So in here I am read all the images from our dataset directory. In here I am using the celebrity high quality image dataset. So in that I am read all the images from our directory and resize the images into 32x32 and convert the color into RGB to PGR, then append all the images into the data directory. So from the dataset I am going to split the dataset into training dataset and testing dataset, because for I am going to cross validate our dataset. So after that I am going to generate the mask images related with our original image size. So based on the original images and mask images I am going to generate the masked images. So from that I am going to inpaint the images by using our local and global refinement network. So after that I am going to build the local and global refinement net. So the algorithm which is constructed based on the encoder and decoder layer. So from that it will takes the overall trainable parameter is 17,18,679. So these are all in trainable form. So as per the trainable per form, so it will train our images. So in here I am applying the 13 different training epochs to generate the validation and training dice coefficient score. On these for the 13 training epochs it will get the 61% for training coefficient results for the light local and global refinement network. So on that finally I'm going to test the images by using the LGR network. So in here it will generate the 13 sample images. So these are all the masked images and mask, and then in painted images, and finally this is the original images. So these are the results for the local and global refinement network algorithm.